This is a video on how to choose a graph, and graphs are something we use an awful lot in biology. Basically, the two main types of graphs you will be using are bars and line graphs, but it's a bit hard to figure out which one to choose. Essentially, if you've got what we call discrete data here, where you have different groups of data that you are comparing, then you will choose a bar graph. That is when your independent variable falls into different categories or groups. If you have an independent variable that is continually changing as well as your independent variable, so it could be the amount of sugar you eat compared to how variable your activity levels are, or how much coffee you drink, how many cups of coffee you drink compared to how your activity or how hyper you are, all that sort of stuff where you have two variables continuously changing, we would then put in a line graph. So we're going to have a look at these in a bit more detail. The bar graph here. With bar graphs, you actually have two ways of looking at bar graphs. If you have just one lot of categories here, which you are comparing, you would have individual bars like this. Now you can actually use bar graphs to compare multiple categories. Now have a look at this one over here, the colors of surviving fish. We are looking at yellow and green and blue fish. They're the different groups that we are actually looking at. Whereas over here we were looking at mosquitoes, honeybees, houseflies and beetles. But in this case too, not only are we looking at these different groups, but we're looking at them in different situations as well. In this case, it's how many generations. So the first generation of fish here, how many blue, green, and yellow fish are surviving in that generation. Then we're looking at in the second, third, and fourth. So this actually allows you to compare groups, but also compare them in different situations, or in this case, across time, so that you can actually get a bigger understanding of the changes that are happening in this group. For instance here, the blue fish actually reduce down as time goes on, whereas the green fish essentially increase. The red fish stay the same, increase, and then decrease. So essentially bar graphs are not always as simple as single bars. You can actually use them to then split up and look at a group in different situations or across different time spans. So bar graphs are not as easy as you have seen them to be so far. Line graphs. Line graphs can be single or double. Now essentially this is what it means. With every line graph you have two variables that are changing over time. One is the one that you control, one is the one that you measure. Okay, so these are two variables continuously changing. If you have more than one line, it's because you have different groups that you are comparing using those lines. So every time you have more than one line, you essentially have more than one group that you are measuring and comparing. This is really important to understand, because people don't essentially get that when there are more than one line on a graph, it means that you have continuous variables, things continuously changing over time, but every time you add a line to that graph, you're essentially adding a different group that you then need to compare to each other. So that's an important thing to understand. We call that multi-line graphs.